Good afternoon to one and all who are present here. Myself, Amuda, working as assistant professor in the Department of Computational Intelligence. I'm going to teach you about machine learning, the basics. The human can learn everything automatically based on their past experience. So similarly, is it possible in the same way the system can also learn something? Yes. System can also learn something from the past data with the help of machine learning algorithms. What is machine learning? Machine learning uses statistical techniques to make a computer more intelligent, which helps to fetch entire business data and it utilizes it automatically as per the requirements. This machine learning enables a machine to automatically learn from the data and improve the performance from experience and predict things without being explicitly programmed. Nowadays, the machine learning can be used in many field like speech and image recognition, traffic automation system using Google Map, object identification and tracking, Google Translation, emergency admission prediction, or statistical data analysis, abnormality detection, self-driving car. So these are the some of the real-time examples where the machine learning can apply in real time. Applications of machine learning. Machine learning can be applied in many fields. In terms of healthcare, it is used to diagnose the disease as well as to predict the emergency admission condition and health status of the patients, and stock market prediction, online fraud detection, using a mobile app and any handheld devices assist the handicapped people, and email spam and malware detection, automation, driverless cars, automation system, product recommendations, real-time traffic signals, traffic condition predictions, speech recognition. So these are the some of the applications of ML. In order to do the machine learning projects, we have to know about the various life cycle methods in machine learning. Like a software development life cycle, machine learning model also follows a certain life cycle steps. First, the data gathering, data preparation, data wrangling, handling of missing data and duplication data, invalid data, and analyze the data, train the model, test the model, and deployment. So these are the various life cycle methods available in machine learning algorithm. In data gathering, based on the problem statement, the required data are collected. Using by using the sensors, we can collect the data of a real-time scenario, or else we can use a benchmark data set. Next stage is data preparation. After data gathering, next we have to prepare the data by reducing some abnormal by deleting some abnormal data, irrelevant data, noisy data, and all. Then the model is that pre-processed data are given as input to the ML algorithm. The ML algorithm has a two-phase, training phase and testing phase. In the training phase, the machine learning model train the given data set, and it infers some knowledge from the training stage. After getting the idea, then if new input is coming, the machine learning algorithm apply the inference knowledge and predict what is happening in the future. So machine learning system learns from the historical data and it builds the prediction model. Whatever it receive that as a new input, it predict the output. So these are the life cycle steps available in the machine learning model. First, the input is given to the machine learning algorithm, and the machine learning algorithm learns some knowledge from the given input and it builds the logical models. This phase, from input phase to building logical models, is called as a training phase. In testing phase, when a new input is given based on the knowledge, obtained knowledge, my ML model is predicting what is my supposed or what is my output should be. So the accuracy of the predicted output depends on the amount of data as the huge amount of data helps to build a better model which predicts the output more accurately. These are the life cycle steps involved in a machine learning algorithm. We can classify the machine learning algorithm into three types: supervised, unsupervised, and reinforcement learning. Supervised learning algorithm, we can say regression analysis, decision tree, random forest, and classification and all. In supervised learning algorithm, we used a data set. So the model is built using the existing data set. For each data set is labeled with the corresponding output. In unsupervised machine learning algorithm, no data set is used. Clustering algorithm, PRR algorithm, clustering algorithms are comes into unsupervised learning. In reinforcement learning algorithm, the model is predicted again and again until the desired target level is achieved. This machine learning algorithm is analyzed based on the performance metrics. So to understand the performance metrics, first we have to know about the confusion matrix in machine learning. This is nothing but is used to determine the performance of the classification model for the given set of test data. It can only be determined if the true values for the test data are known. This matrix itself can be easily understood, but the related technology may be confusing. It has a 2x2 matrix. So the rows should be a predicted output, columns should be actual output. For predicted output and actual, true negative, first row, second column false positive, second row, first column false negative, second row, second column true positive. So true negative, it is nothing but the model has given a prediction no, and the real or actual value was also no. In true positive, the model has predicted yes and the actual value also true. In false negative, the model has predicted no, but the actual value was yes. It is called as a type 2 error. In false positive, the model has predicted yes, but the actual was a no. It is called as a type 1 error. So the numerical explanation also given for the confusion matrix. This table gives a two class of a classifier which has the prediction yes or no. Here the yes defines that the person has a disease and no defines the person does not has the disease. This classifier has made totally 100 prediction. Out of 100 prediction, 89 are true prediction value and 11 are incorrect predictions. The model has a given prediction yes for 32 times and no for 27 times. Based on this confusion matrix, the model performance analysis can be calculated. So the classification accuracy is an important parameter to determine the accuracy of the classification problem. It defines how often the model predicts the correct output. It can be calculated with the ratio of accuracy equal to true positive plus true negative divided by total number of prediction happened in that model. The second metric is misclassification rate. It is also termed as a error rate. It defines how often the model gives the wrong prediction. The formula for the given misclassification rate is error rate equal to false positive plus false negative divided by total number of prediction. Then the third metric is precision. It can be defined as the number of correct output provided by the machine learning models based on the all positive cases that have the predicted correctly by the model. It can be calculated using the formula precision equal to true positive divided by true positive plus false positive. And the next metrics used in for the performance analysis is a recall, which is nothing but out of total positive cases, how our model is predicted correctly. So the recall can be measured based on the formula TP by TP plus false negative. F measures, if two models have the low precision and high recall, it is difficult to compare those models. So for this purpose, we use a F-score value. This score helps to evaluate the recall and precision at the same time. If the F-score value is maximum equal to the precision, we can say the model is a good model. So F-score is calculated by the formula 2 into recall into precision divided by recall plus precision. In a machine learning model, there may be a two problem happen, overfitting and underfitting. These are the two main problems occur in the machine learning model, which is used to degrade the performance of a ML system. So the main goal of machine learning model is we have to generalize the model well. The generalization is nothing but the ability of a ML model to provide a suitable output by giving a proper set of input data. So it means after providing training on the data set, we can produce a reliable and accurate output. uh, some of the terms we should familiar in order to understand the ML model working principles clearly. We should know about signals. It is nothing but the original data, the underlying pattern of the data that helps in machine learning model to learn knowledge from the data. Next, noise, which is nothing but the unnecessary or irrelevant data, which reduces the performance of the model. Bias, bias is nothing but the prediction error, which is introduced in the model due to oversimplification of the